Welcome to section 6.7, and here we are talking basically financials. Every single one of these questions deals with the financial aspect, and we have looked at these formulas before, so as we need them I will bring them back up, but until then we'll just start with the examples, just like always. So we start out with number one. Number one, we have $14,000 invested at 10% compounded semi-annually after a period of 4 years. And we want to know how much that's going to result in. And so this uses this formula, and this formula you do need to learn. The amount is the present value times 1 plus r over n raised to the nt power, where r stands for the rate, p is the principal, how much was invested, n represents how many times per year it's compounded, and t represents the number of years. So with that in mind, all we have to do is plug in the values. We get 14,000 times 1 plus, okay, 10% is 0.1, over semi-annually is 2 times a year, and it's 2 times 4. Okay, so this will equal 14,000, 1 plus 0.05 raised to the 8th power, or 14,000 times 1.05 raised to the 8th power. And then it's just a matter of plugging that into a calculator. And so when we do that, 14,000 times 1.05 raised to the 8th power. And that equals $20,684.38. And there's the answer to number one. Number two, we invested 12,000 compound or at 7%, compounded quarterly, so that's 4 times a year, and after 7 years is what we want to know. So once again, I just put it in, and now it's time to plug and chug. Let's see, 0.07 divided by 4 and added to 1 is 1.0175, and 4 times 7 is 28. And so when we take 12,000 times this raised to the 28th power, we get approximately $19,504.95. 3 and 4 ask us to find the effective rate, and we need to remember that one. The effective rate is equal to 1 plus r over n raised to the n minus 1. So you'll need to remember this formula as well. And we are asked, it's 75.06% compounded daily. So all we have to do is plug that information in. 1 plus, okay, 0.7506 compounded daily means there's 365 days in a year. And then this all equals, once we just punch it all in, is 1.1166, which actually represents 111.66%. 111.66% is the effective rate. Example 4 isn't quite as crazy, because that's quite a rate of return. Let's see. The effective rate is 1 plus, okay, 4 3/4 is 0.0475, and it's compounded quarterly, so that's over 4, then raised to the 4, and then subtracted 1, and we end up with 0.0484, which ends up being 4.84%. Now in these problems, just take it out. At this stage, take it to 4 decimal places, so that will allow for 2 decimal places in the final answer. Number 5 asks us to compare and see which one gives the better rate. So we are looking for the effective rate in both instances. One of them, and it's all in 1 year, so it doesn't really matter because 1 year effective rate is based on 1 year. So we have 9% compounded monthly, and we have 9.25% compounded annually, so that's only 1. And let's see which one is bigger. This one, when we plug and chug, it becomes 0.0938. Sorry about that. And this one is 0.0925. If it's compounded annually, the effective rate is the same as the stated rate. And so, excuse me, the better one is this one, which was the monthly compounding. Number 6. I feel like I'm going to choke here. Number 6, we're asking the present value. Now the present value looks very similar to the final amount. There's only 2 big differences. We switched the P and the A, because we're looking for the present value. And the other big part is, instead of raised to the NT power, it's raised to the negative NT power. And that's the only difference between the first one that you needed to learn and this third one that you need to learn. So we want to get $2,000. That's what we want to get eventually. When it's 9% compounded semi-annually, which means 2 times a year. So that'll be -2 times t. So let's see what all we need to do here. This is 2,000, and then this becomes 1.02 raised to the this is 7 years, not t. What am I thinking? I thought it was sort of strange. 7, so raised to the -14 power. And then plugging and chugging away, 2,000 times 1.02 raised to the -14 is $1,079.95. So what that means is we have to put in $1,079.95 into an account that pays 9% compounded semi-annually, and after 7 years we'll get $2,000 if it just sits there. Example number 7. How much money needs to be invested now to get 2,000? Express your answer to the nearest dollar is what it says. So let's see. This is the present value is equal to, okay, how much do we want? We want $2,000. The rate is 8%. Compounded quarterly means 4 times, and it's going to be 4 times the 4 years that we have. Okay, so this will be 2,000. This is 1.02 raised to the, whoops, that has to be negative, I forgot. One of the two things I had to remember. To the negative 16 power, and then plugging and chugging here, 2,000 times 1.02 raised to the negative 16th power, and rounding to the nearest dollar is $1,457. So once again, if we put that amount into this account 4 years later, we would have right at $2,000. Realize this number right here that I said previously for number 6, this obviously is not 1.02, but I can't go in and change it right now. This should be 1.045. I just jumped ahead and looked at my work for number 7. So realize this is the correct answer if this number was correct. If you try to punch this into your calculator, you will not get the 1079. But if you put in the 1.045 that should be there, you will get $1,079.95. Okay, let's look at number 8. Number 8 asks, how long will it take for an investment to double if it earns 5.75% compounded continuously? Okay, here's the continuous problem. The amount is equal to P E raised to the RT. Remember, this is the formula for the continuous thing. And so what we get is we have a certain amount. Let's just, for simplicity, let's say we've got $1 and we want to know when will it double. So when will it become $2? Equals E raised to the, okay, the rate is 0.0575, and we want to know what is the time. Okay. So we divide both sides by 1, which is easy enough. 2 equals E 0.0575 t. Now to get rid of this e raised to this power, we have to do logarithms. So we need to take the natural log of both sides. And if we remember back to the last couple of sections, this is what we will get. Then, to solve for t, we just take the natural log of 2 and divide by 0.0575 so that we get t all by itself. Now remember that t is in years. And so we're going to take the natural log of 2 and divide by 0.0575. And that will equal 12 point, it says what, 3 decimals? 12.055 years. Takes a little bit of time, even being compounded continuously. Okay, number 9, final problem. Gillian has $10,000 to invest in a mutual fund. The average annual rate of return was 12.25%. Assuming this rate, determine how long it will take her investment to double. I guess it's Jillian instead of Gillian. So we are not compounding continuously. In fact, it is an annual compounding. So we want to know, suppose we start out with $1 at 12.25%, compounded once a year. We want to know how many years will it take for that to double. And so divide both sides by 1. In other words, 2 is equal to this. And then let's go ahead and simplify this. This is 2 equals 1.1225 raised to the t power. And here we have a power, or an exponential, so to get rid of it we need to take a logarithm, and we're going to have to take the log base 1.1225. So we're going to take the log base 1.1225 of 2 will equal t. Well, that's not terribly difficult to do. We can do it. Oh no. And I just lost everything. Did. So let's quickly repeat that. I was at this stage. 2 equals 1.1225 raised to the t power. And so I took t equals log base 1.1225 of 2, which using the change of base is the log of 2 over the log of 1.1225. And this equals, and it asks us to, it doesn't give us any particular decimal places, and so we just need to do a logical rounding, I guess. And so we'll do the logarithm of 2 divided by the logarithm of 1.1225, and that equals 5.998. That is certainly close enough to 6 years. And that is the final answer for this problem.